Hey guys, Mr. Bowman here. Today's learning objective is at the top. We are learning to identify the formulas of given trig graphs, but we are learning to do that in radians. So what I've got is here, this is the screen that we left off on the previous video. We learnt that a full revolution was 360 degrees. That was the measurement in degrees. But that is also can be referred to in radians, which is 2 pi. We learned how to switch back and forth between the radians and pi. What we're learning to do today is how do we identify the formula of given graphs in radians. And what I'm going to do for that is I'm going to pause this video, I'm going to switch to the paint and Desmos combo, and we're going to get into some questions about how to use Desmos and the features of a graph in radians instead of degrees. Okay, so I'm going to pause this. Okay, so we are now on Desmos, just got the stuff on paint. Just to recap, we were practicing in degrees, we're now shifting over to radians. 360 degrees is 2 pi in radians, and we're going to use sine as an example, A, B, C, and D in there as well. The first step we need to do, no matter what tool we're using, we need to make sure we're operating in radians. So for Desmos, what we need to do is, degrees is in green, we need to switch to radians. So that'll help with that. And you need to make sure you need to make sure you know how to do that on your graphics calculator as well. I will have a video explaining or showing how to do that in the graphics calculator in the description below. And what's going to happen is the pi, or now that we're wanting to know things into pi, I'm going to change my x value steps into terms of pi. And what you can see is you can see in the x-axis, it's now all measured in pi. And so that'll be really useful helping that out. If it wasn't, it would be measured just 1, 2, 3, 4, 5, 6, and you'll need to roughly estimate or use the numbers instead of versions of pi. Okay, so what I'm going to do is I'm going to write an equation. So let's say y equals sine x. That's our basic equation, and we can see it has a height of 1 because it only goes up to 1, and a minimum of -1. And we can see that half cycle happens within pi and that full cycle happens within 2 pi. So in terms of B, or the number of periods that fit within a cycle, we're now referring to 2 pi's. So how many cycles will fit within 2 pi's? D and C, they are the same thing. D, how much does it move up and down, unaffected, and C, how much it moves left and right. That's not affected, only affected in the sense, instead of doing like 100 degrees, you now might be doing 0.2579 or 0.1 or half a pi or something along those lines. And A, again, A is not really affected. A is the amplitude, how much it goes up and down. So no real impact. But let's get into some questions to see how it works here. So I'm going to make an example up. So I've got 2 sine, and then that's going to be, B can be, let's say, 3. That means we should hopefully see 3 cycles within that 2 pi range. Plus, let's just move it across 1. See what that does to it. And then we're going to increase that by 1. So if you have a look at our graph, so let's have a look. What did that 2 do? So if you have a look at the center of the graph, so it appears to be at 1, just over there, we can see it's now going up and down 2 as opposed to going up and down 1. What did that 3 do? Let's have a look. So here's 0.22. So we should be going slightly after 2 pi, which is here. And we can see that 3 makes 3 revolutions within that 2 pi range. So let's go 1, 2, and then a 3rd revolution as well. So we've now got 3 revolutions within 2 pi. That plus 1, well, what's happened is that plus 1 has moved it across to -1. So we can see this value, so we can see it's been moved towards -1. So this value here, so let's copy and paste this formula and get rid of the plus 1 just to show what it did. There you go. So this value, it should start at 1 because that's how much it's been moved. So it should start at 0, 0, it's been moved up 1. And we can see the vertex, it should be up there, 1 pi of 6. And what's actually happened is we've subtracted 1, which has moved it plus 1. So every point's been moved plus 1. And just to note, the other way to think about it, it should have started up here, but it also moved the other way. So you may want to consider the 0 and the 2 pi range number as well. And the last one is that plus 1. We can see it should have been at 0, 0, and now it's been moved up. Or the center of that trig graph is 1. So guys, this is just a short video recapping trig graphs and radians. Key principle is very, very similar concepts to what we are working on with degrees, except instead of dealing with big numbers along the x-axis between 0 and 360, we're now dealing with terms of pi. So a full revolution, let's draw another graph, let's do cos x this time. A full revolution of cos x starts and finishes within 2 pi as opposed to within 360 degrees. Hopefully you found this video useful. Now I've got 4 questions for you. Let's get into some examples of using pi instead of degrees. Okay, let's go.